we're continuing talking about slope-intercept form today. So let's remind ourselves from last time what that looks like. That's the equation y equals mx plus b. So this is for linear equations, graphs that looks like lines. Remember, this is the most common form that we'll use to write an equation for a line. Now, you need two things about the line to be able to write slope-intercept form. And the name gives it away, you guys. You need the slope, which is represented by the m in my equation here. And you need the y-intercept, which is the b value. So the slope tells how steep the line is, and the y-intercept tells where my line crosses the y-axis. Okay, if I know those two things, I can write this equation, I can graph it. I know a lot about the line. If I can have slope-intercept form, or if I can write slope-intercept form. So we're still talking about that same topic today, and we're still focusing on graphing lines. We did a little bit of this last time. We kept it pretty basic though in the first lesson. So the difference between the graphs in today's lesson compared to the ones from last time are that today's linear equations, don't let that word throw you off, that just means the graphs are lines. Today's linear equations are not already in slope-intercept form. All of the ones last time that I had you guys graph, the line was already written in mx plus b. Today, they're not going to be written in mx plus b. Okay, so that is like the main goal for today, being able to write it in mx plus b, then you just do exactly what we did last time. So the big idea for today's lesson is to remember that before you can graph the picture of the line, which that's what I'm trying to get at here, but before I can do that, I have to get it in mx plus b first, so I can pick out the slope and the y-intercept. And you guys, that means that y has to be alone for it to be in mx plus b. So you're going to need to solve for y first if you don't already have y by itself. So if you look at example 1, I have y by itself on one side of the equation, so this is in mx plus b. So this one's kind of review from last time. It looks weird. This one would throw people off. Remember the steps from yesterday, and if you need to get out your notes from last time, do it. But the first step for graphing in mx plus b was to pick out the b value, the y-intercept. This one would throw people off because the b value is 0. So that's where I'm going to start. My line crosses the y-axis at 0, so plot a point. Then I count the slope from that point. Now the slope is just m, what's sitting in front of x. In this case, it's negative 1 over 1. So remember we said always count your slope right. The top number tells you up and down. And since it's negative, I'm going to count down 1 and then right 1. Down 1, right 1. You plot as many points as you want, but once you have 2, you're ready to draw the line. So that would be what the line looked like for number 1. Okay, that's kind of review. Number 2 is where we get into what's, I guess we'll call new for today, but it's really just combining two different skills. You guys all ripped on these problems when we did them in Unit 1, but remember when they gave you a formula in Unit 1 and you had to like move stuff around to solve for a variable? That's where that skill comes in. So I need to get y by itself. I have x's in there. I want an x to be in there because I'm thinking mx plus b. So basically just shuffle stuff around until you have y alone. So on number 2, if I can get this 2 to the other side, I'll be good. So I know to do that, I'm going to divide by 2. That'll cancel that 2 out. Now, when you come to the other side, I'm going to suggest that you write it like this. Divide everything individually by 2. So then I can write it in mx plus b. So I'm going to have y equals. I know that I want slope to be written as a fraction. So I got to think what fraction is in front of the x here. Well, I know that a 1 is sitting in front of x. So really, you guys, that's the fraction 1/2. So I'm going to pull that out front and say 1/2 x plus 4 divided by 2 is 2. Okay, this is what I want to graph. Now it looks like last time. This is an mx plus b. If you just divide everything by 2 instead of doing it individually, it will be harder to see the slope and the y-intercept, which I know those are the 2 things I need to graph. So the b value is 2. So I go up to 2 on the y-axis and plot a point. And then I count my slope. So I always count right, what the bottom number is. The top number is positive 1, so I'm going to go up 1, right 2. Up 1, right 2. Connect them. There's my line. All right, example 3. So same thing. All that's different is I have to solve for y first before I can graph it. So to get y by itself, if I just move this minus 2x to the other side, I'll be good. So move the whole term by just adding it over. Then you've got y equals, you guys, if you want it to be an mx plus b, you want to write the x term first. So I'm going to put 2x first and then say minus 3. Then it's a lot easier for me to see, like, oh, the y-intercept is negative 3. And my slope, I could make that a fraction, 2 over 1. So the top number is up and down, so I'm going to go up 2 and then always write, and write 1 in this case. If it drives you nuts not to use a straight edge, use a straight edge. I don't know, I feel like my lines are pretty decent without using one, so I'm not going to be picky about that part. All right, I want you guys to try number 4 on your own. Number 5, ooh, this looks weird, but again, the whole goal is to get y alone, so there's y. I need to move everything else to the other side. So move what's not connected, move the 5 last, and move your minus 3x over. And you do that by adding it, come over on the other side, and add it to the other x term. Right there. Alright, so let's see what's left. I have more than one step on this one. So it's 5y equals, okay, this is weird. Negative 3x plus 3x, that cancels. That's 0 x's. And then minus 5. Technically, I didn't have to write the 0x, but I'm going to leave it in there, and you'll see why. Now I still got to get y alone, so I'm going to divide by 5, and I'm going to divide everything individually by 5. And now I've got y equals 0 divided by 5, that's just 0. 5 divided by 5, that'd be minus 1. So I can leave it like this, or realize I don't even have to write the 0 x's. I could just say y equals negative 1. Ooh, this one's weird, and I'll tell you, in the future, they won't write 0 x's. They'll just write this. And that leads nicely into a problem that we're going to do at the bottom here. But for the sake of like what we know right now, let's graph this line right here. You should all see that the y-intercept is negative 1. So go down 1 and plot your point. The slope is 0. I mean, you could make that a fraction and do 0 over 1. So basically, like, you don't want to go up or down because the top number is 0. You just want to go right 1. So you just like keep going right 1, which is kind of weird. This is one of the special cases. It's not that special, but that's what we call it. And notice this is a horizontal line, so this is a special case, which we're going to talk about down here at the bottom. So we'll kind of hold off on that one for now. Let's finish up with number 6 before we get there. Okay, so this kind of looks weird. I have to do something on both sides. Like, I would see the distributing right there, and I would take care of that right off the bat. So that'd be 6x minus 6. Then I would say, all right, if I just add 2 to the other side, I'm going to have y by itself. Okay, so there's my line. Now I want to graph it. So you go down 4 on the y-axis, and then count your slope, which would be 6 over 1. So it's positive 6. I'm going to go up 6 and right 1. The bigger the slope, the steeper the line. So that's a pretty steep line right there, 6 over 1. Okay. Now, I will say you guys are using a lot of different skills to be able to do this. And it's things that we've learned like along the way in this class. So if you can get these right, you're doing pretty good. All right, at the very bottom, so let's talk about a little bit more about the special cases. They're horizontal and vertical lines. So here's kind of one of each. These look weird to people, and oftentimes this concept is pretty difficult for everybody to remember. So pay close attention because they're still lines, but they're going to be mixed in with all the regular mx plus b lines, and you got to recognize when they happen. So if I look at number one, there's a couple ways to do this. I'm going to give you like a few different ways to remember, and hopefully something sticks with you. You could think of this as we did like number 5 up here. Like I just see a Y. So the X's are gone. If the X's aren't even written, you guys, then that means that there's 0 X's. So you could rewrite it like that, and you could graph it exactly like I did number 5 up there. Another way that some people remember how to do this is know that, like, think of this for I-step 2. If they ask you to graph something and you have no idea what to do, you can always go back to making a table. Remember we did that last lesson? We did like -2, -1, 0, 1, 2. You only need 2 points to make a line. So maybe I'm just going to do -2 and -1. And you could pick anything in this case. Look at how you'd fill this out. So like there actually is no x, which is kind of weird. And the way that this equation's written, they're trying to say, hey, y always equals 4. So like you can pick whatever the heck you want for x, but y should always be 4. So then I could just plot those 2 points and connect them. If I would have used this equation, I would have started at 4 and I wouldn't have gone up or down. I just would have gone right 1. So guys, whatever way you do it, you're going to get a horizontal line. There's a couple tricks some people use to remember this. One of them is honestly so stupid, and it's a little saying, but sometimes the stupid sayings can help. Horizontal. A horizontal line starts with y. Really stupid. But again, sometimes the stupid things help you remember. I see a lot of people say, okay, well the y-axis is the one that goes up and down. So if it's a y equals equation, then it's going to be the opposite of the axis. And it's going to be a horizontal line. Okay, whatever way you swing it, if it just has a y and no x's, it's always horizontal. Flip that idea around and say it just has an x, like there is no y. This one's a little weird. I couldn't really use this trick right here. Maybe I used the table trick. Look what this equation's saying. It's saying, hey, x always equals -2. It's like, it doesn't matter. X should always be -2. So maybe I come over here. You can pick anything you want for y because it doesn't exist in the equation. So maybe I just do like 0, 1. And then if I just plot those 2 points and connect them, it'd be this line right here. There is a stupid saying for these. If it's just an x, it's vertexal. I don't know who made that up. Do not think that I made that up. I didn't. I have a life. Okay, so if it starts with an x, it's a vertical line. Again, some people like to think, oh, the x-axis is this one. So an x equals line should go the opposite way, and it's vertical. And I'm just going to find -2 on the x-axis, and it goes through that point. All right, again, whatever way you choose to remember it, I don't care. We'll practice these. They'll be mixed in, but just note it at the bottom. If it's a vertical line, that was like number 2, it always starts with like x equals just a plain number. Remember from a couple lessons ago, vertical lines have an undefined slope. There is no slope. It's not even there. It does not exist. The horizontal line always starts with y, and those have a slope that's 0. Okay, so be aware that those kind of will be mixed in along the way.